Good morning, everyone. My name is Johnny Mayer. I am a plan and spec salesman for Wallace Ennis Associates. Wallace Ennis Associates is your source in New York, New Jersey, all 5 boroughs, Long Island, into Westchester, most of northern New Jersey, for quality products for HVAC needs. Who are we? What do we do? And how do we achieve success? Well, thank you for asking. We do that with the 360 experience. At Wallace Ennis, we are dedicated to ensuring our clients' buildings and residences provide comfortable heating, cooling, and domestic water as expected. We do this by taking a 360 approach. Understanding our customers up front, we utilize a suite of products and services throughout a project to ensure HVAC and plumbing systems are designed, installed, and maintained to reduce capital equipment costs, maximize efficiency, and to extend the life of the equipment. Our end of project review and service guarantee provides peace of mind that the project was completed as expected and with long-term monitoring to ensure future performance. We've been answering the call for 95 years for your project and assistance. We always provide the industry-leading products and services. When needed, we innovate innovative solutions to meet demanding project requirements, as there always are in New York City. And as anticipated, we are your trusted partner in meeting your expectations for projects. So the 360 experience has a few arms to it. First is Hydrosource. This is for both residential and commercial. We have an inside support team, outside support team, who can provide you with all the systems, the sizing, equipment, pump selection, boiler selection, anything you may need. And that brings us to HydroMax. HydroMax is for more turnkey solutions. This is where we can develop with property managers and facility managers. We can service. This is for existing projects, fit outs, new projects, you name it. And then HydroFab. So this is more for our commercial clients. We can package boilers, skid pumps. We can greatly reduce labor costs while accelerating timelines and ensuring that everything's installed properly. We'll wire it for you. We'll pipe it for you. You're just dropping it in the building. And don't forget to ask about complete solutions where we're dropping full boiler rooms right onto roofs. Really interesting stuff. So who are our manufacturing partners? Here's a list of them right here. Now, the main ones that we're going to focus on today is going to be Bell & Gossett. This is going to be a pumping class, but there's a lot of other big ones here, including Lochinvar. Tisdale is for our packaging and modular, like we just touched on. And here's a few projects that we've done, and I know a lot of you guys are project managers watching this video. Hopefully some of your projects got highlighted here. So today we're going to talk about pump installation options for variable speed, IT and ITSC. So what is sensorless? The drive is mounted on an integral with the pump motor. It's as simple as that. It does have some cost advantages. You don't have to wire the VFD to the motor. You also don't have to mount them on a nearby wall, so you save that wall space. Bell & Gossett offers ITSC, integrated technology with sensorless control. This is true sensorless. There's also IT. This is just integrated technology. This is the model shown above with the VFD mounted to the motor, but isn't necessarily sensorless. You would still have to wire a DP into the system. Both are available. So how does the sensorless technology work? So basically, they are simply mapping the system and pump curves into the drive at factory. They know where the pump is running based on the speed and power draw. Based off the power draw, B&G is able to speed up and slow down the pump so it'll continuously be on your system curve. As system valves closes, a reducing demand, the system curve wants to move to the left. The drive combines the speed with the horsepower draw and interprets this as a reduced demand and slows the pump down to hit the system curve. In this example, if it suddenly jumped to the duty point, about 680 at 100 here, roughly, it knows where it is based on the combination of hertz or speed and the horsepower draw. It knows that it's moved off the system curve and will slow down the pump to about the equivalent of a 8 3/4 inch impeller. So down from a 10 1/4 inch impeller to 8.75. That's a turn down of about 15%. The pump would slow down from approximately 1800 RPM to around 1500 RPM. On the flip side, an increased demand, a call for heat, let's say, moves out right on the curve and the pump speeds up. Running off the curve means the control valves are starting to open up again and the pump sees this. It reads this, that you're moving off the system curve and speeds up to compensate for the higher demand and brings it back onto its curve. It's important so some things that are important to remember. during setup, you would actually reset the system curve to match the actual total dynamic head. If not set up correctly, the pump will speed up, wasting energy to hit the system curve. So we're operating under the assumption, which is 99% of the time it's true, that the head is overestimated. So to make sure that you find the true TDH once the pump is installed, and startup Wallace Ennis technicians will come and visit every site where we sell an integrated technology pump or an ITSC sensorless controlled pump. We will be there to assist with startup if there's any issues here whatsoever. A few more notes: when you're laying this out, you need to keep code clearances depending on the voltage in front of the drive. You'll find this in your I&O manuals and in business and in the building code manuals. So you want to make sure you have access to that panel. These are right on the pump, so sometimes these are being put up high, or just make sure you have the clearances required. You cannot get bypasses with these pump-mounted drives. And again, Bell & Gossett, we don't really recommend bypasses, just generally speaking. This is sort of a relic of the past that still somehow kept its spot in specifications with the engineers a lot of the time. VFDs now are more reliable. Anytime you have spare pumps, 100% pump, or even a 50% pump, you can't run one of them in bypass and one of them on the VFD. You're better off just having that spare drive if it's a big concern. So Wallace Ennis does not generally recommend a bypass on the VFD when there is a spare pump, even if you're doing loose VFDs and they're not available in this. So for our applications, there's almost always a spare pump, at least 50% load. And for that to function properly and for you to get your turn down and your efficiency, you're not going to want to bypass. So people will tell you the Centralist Design saves money operationally. Okay, as compared to what? They'll say 40%, 30% versus constant speed? Yeah, obviously. That's the only way you're saving 20, 30, 40% using Sensorless. You can use the Centralist configuration, basically a VFD mounted on the pump, and still bring a DP signal in like any other conventional remote DP design. That's still an option. You'll get the wall space savings. You still get the no wiring outside of that DP switch, obviously. So Centralist Design saves money operationally, again, as compared to what? So basically, the worst way you can install a pump, constant speed. We all understand that. That's obvious. You're not getting any turn down. You're just running full blast or not at all. The next worst would be controlling the speed based on a DP that is being located just across the pump where it's installed. This is a cheap option because you don't want to run that DP sensor to the end of the run. You're just getting across the pump. And it's just sensing that, so you're not going to get the full drop right outside of that farthest coil where it should be installed. The second best option would be sensorless. So sensorless basically is taking the reading right at the pump as it would be if you put the DP basically right on the other side of the pump, except that at factory they've built in the curve and they've got a few extra readings they get, namely that horsepower draw. They know the power draw, so they are able to ramp up and down more efficiently than if you went right across it. Still, the best install is to put your DP sensor at the far end of your system. That's still going to be the best turn down. That's going to be your most accurate reading through your system, and that's going to be your most efficient way to install the pump. Now, we understand sometimes it's really costly to run the DP sensor at the end of the system. With two of them, sometimes you got to run two DP sensors for both pumps. It's understood. So that's where Sensorless would be a good option if that runs too far, or if you need to save those savings, or just have somewhere you can't get. So what's the break point? I'm not sure. Everyone has their own opinion. It's also a bit of a question, capital versus operating costs. To answer the question, 5 horsepower, 10 horsepower at most. You should probably use the Sensorless. Other than that, you're going to want to use a DP at the end. So any of these bigger systems, you're going to want to run a DP. In my opinion, you can still use the pump-mounted VFD configuration. Just bring a DP signal to it rather than using the Centralist Control. You're still saving the VFD, the wiring, and that wall space. For smaller applications, we have these ECM pumps. Now, these are available up to, I believe, 2 or 3 horsepower now, and these will cover a lot of the smaller installations that you can run with all the benefits of Sensorless. So you see your control module is mounted right on this thing. It's basically a DC motor. It has a built-in rectifier and electronic controls. It's brushless. It minimizes losses. and therefore it's very efficient. Energizes the winding surrounding with permanent magnets. They have internal communications. You can daisy chain 2 of them to run lead lag or run standby. You can do that all internally to these pumps. These are the Ecocirc XLs, by the way. The head and flow range with electrical options is right here. The line has been newly expanded to include 115 volt single phase options, which is great with a control head. Normally, if you're running a VFD and you wanted it to be single phase connectivity, you'd have to get 3-phase motors, This eliminates all that in these smaller sizes, just a lot easier to install. Again, you have all the benefits of the sensorless and the IT. Nothing to wire, just one install right in line. These things are small. You don't really need to support them very much. Very easy. They also have extended a lot of the bigger ones to a true 208, 230, 460 3-phase option. So we can cover most of your bases here. There's some models only come in 208, 230 single phase, but that's just a few middle sizes. So your bigger ones, you can go 230, 460, and a lot of the smaller ones, you'll be in 115. So we can cover almost every need that an engineer may lay out for you. And here are the curves. So every one of these pumps comes in cast iron for heating, stainless steel for domestic use. We've got high flow and high head options. So as you can see, we can cover out pretty far. We can get a lot of flow at low head. You know, if you look at the 45, 375, or we can get a lot, you know, almost 90 feet ahead for, you know, 20 GPM. That's pretty big. We can cover most ranges you can come up with here, up to about, you know, any 3 horsepower or something along those lines. So you can set it to maintain constant speed, constant pressure, or any other simple settings. You can also use a remote DP if you want. We're talking low horsepower though. Usually small systems are loops, so a DP 10 feet away doesn't make a whole lot of sense. You might as well use the technology within, but it's an option. So we've just demonstrated the latest technology and the best state-of-the-art equipment for overall efficiency and return on investment. I think you would agree that investing in a quality product like we've shown you makes sense, don't you? Yes, thank you. So I can count on you to use our brand on your upcoming projects, correct? Thanks, guys. Thanks for watching. And stay tuned. We're going to have a lot more of these training videos, and we will talk to you soon. Thank you.